So please remind me next time to start the recording because I'm missing this thing every day. Okay. So I'll repeat this thing. So if you take the mnemonic diagram, is a rectangle. The four sides have the energy functions A, G, H, and P in alphabetical order: A, G, H, and S, H, and U. Then A is a function of V and T, G is a function of T and P, H is a function of pressure and entropy, and U is a function of volume and entropy. So we write these two term variables V and T on the two corners of this rectangle. V and T. T has to come on this side because G is a function of temperature, and then this side will become P, the other side of this G, and pressure is already there, so H and S, H will have P and S on the two sides of the rectangle, and you will have V and S on the two sides. If we write dA, the derivative of A, it is a function of V and T, so we will have dV and dt terms, and the coefficient of dV will be opposite to that is pressure, yeah, so P dV, and the coefficient of T will be opposite to that is S, so S dt. And the sign will be, if the arrow is pointing towards the dt and dv, it is negative, so minus S dt and minus P dv. Now if you write for dg, dg is function of temperature and pressure, so it is going to be dt and dp. The coefficient of dt is S, which is opposite to T, so S dt, and the coefficient of dp is V, which is opposite to dp, or P, which is, so it makes it V dp. Now in this case, the arrow is pointing towards T, so the sign of SGT will be minus, and the arrow is pointing away from pressure, so the sign of VDP will be positive. Similarly for H, dH is equal to a function of pressure and entropy, so dP, and ds will be there. The coefficient of P is opposite to that is V, so it is VDP, and the coefficient of S is opposite to that is temperature, is TDS. Now the arrow is pointing away from pressure, so the VDP term is positive, and the arrow is pointing away from S, so the sign of TDS is also positive. Similarly for U, you can write du is equal to function of V and entropy, so dV and ds will be there. The coefficient of ds will be temperature, which is opposite to S, so TDS, and the coefficient of dV will be opposite to that, which is pressure, which is PdV. And the sign will be, because it is pointing away from S, so it is positive for TDS, and if the arrow is pointing towards V, so it is negative, so minus PdV. So that is how we write the fundamental property relations from the mnemonic diagram. So I'll save this as some document and keep it. Then I'll share it with you. Okay. So any doubts on this much so far? Okay. If no doubts, then we'll move on. I'll share that PDF. So fundamental property relations are over. We will move to Maxwell equations. We have done one derivation yesterday, so we'll complete all the derivations today, and then we'll go to the mnemonic diagram for Maxwell equations, all of them together. So I'll repeat this Maxwell equation derivation which we did yesterday. So we start with du is equal to TdS minus PdV. So we take at constant volume, this term becomes 0 at constant volume dV term. So what we get is W by WS from here at constant volume is equal to this temperature. So this term is 0 now. Then we take a differential with respect to V at constant S. So first we have taken constant V, then we take constant S. These are two variables used as function of V and S. So what we'll get is W square U by W V with respect to V and W S is equal to W T by W V at constant entropy. Similarly, same equation, now we take at constant entropy, what happens? So ds becomes 0. So what you get is W by W V from here at constant entropy is equal to minus P, this term is 0. Now we have taken constant entropy, so next time we differentiate with respect to S at constant volume. So one time constant S, second time constant V. So what you get is W square U by W S W V is equal to minus W P by W S at constant volume. So if you compare equation 1 and 2, the left hand side is the same. So right hand side has to be equal. So what we get is W T by W V at constant entropy is equal to minus W P by W S at constant volume. This is one form of Maxwell equation. Any doubts, questions on this one? We had done that yesterday, it was just revision. Okay, if not, then we proceed to the next one. That was using internal energy equation, fundamental property relation. Now let's use enthalpy relation. So dH is equal to TdS plus VdP. So at constant P, dP will become 0. And what we'll get is WH by WS from here at constant P is equal to temperature. Then we take differential with respect to pressure at constant entropy. Because you see H is a function of entropy and pressure. So one time we take constant pressure, other time we take constant entropy. So what we get is W square H by W P W S is equal to W T by W P at constant entropy. Again, same equation. This time we start with constant entropy. Last time we did constant pressure. Now we do constant entropy. So what we'll get is WH by WP from here at constant entropy is equal to V. Now this is 0. ds is 0 because entropy is constant. So now we take constant pressure and differentiate with respect to S. So what we get is W square H by WP WS is equal to WV by WS at constant pressure. We done similar to what we did for internal energy. First we take constant pressure, second time we take constant entropy of first equation or equation 3. Then we take constant entropy and then constant pressure for equation 4. And if you compare these two equations, equations 3 and 4, left hand side is same, so right hand side has to be equal. Any doubts on this? No? So what you get is T by P at constant entropy equal V by S at constant pressure. This is another form of Maxwell equation. Any doubts, questions on Maxwell equation derivation so far? The objective of all this is that we have what? Temperature, pressure, volume and entropy, right? If you really see, there are 4 variables. Let me see. I can show you the Maxwell. So we have four variables: temperature, pressure, volume, and entropy, right? Entropy is something which we cannot measure. Volume we can measure, temperature we can measure, pressure we can measure. So we are trying to correlate entropy with other variables so that we can find entropy using measurable quantities of temperature, volume, and pressure. And that's what we will be doing. We will be substituting for entropy using Maxwell equations in our derivations. Right? So you have one form of equation, again temperature, pressure, volume, and entropy. And here also second form of equation, temperature, pressure, volume, and entropy. Three measurable quantities, one quantity which cannot be measured. So we have to get a correlation for that in terms of measurable quantities. Okay, so next is dA is equal to minus SdT minus PdV. So we take at constant volume, dV is equal to 0. What we get is delta A by delta T from here at constant volume is equal to minus S. Now we differentiate with respect to V at constant temperature. As we see, this is dt and dV. So function dA is a function of temperature and volume. So first time we have taken constant volume, second time we take constant temperature. So what we'll get is delta square A by delta V delta T minus delta S by delta V at constant temperature. Okay. So we get equation 5. Similarly, we take the same equation, this equation for dA at constant temperature. So dt will become 0. And what we get is delta A by delta V from here at constant temperature is equal to minus P. Then we take this equation and differentiate with respect to T, is T, at constant volume. What you get is delta square A by delta V delta T is equal to minus delta P by delta T at constant volume. So first time we have taken constant V and then constant T for this equation. Then here constant T and constant V for this equation. And if we compare equation 5 and 6, what you get is left hand side is same. So what you can say is right hand side has to be equal. And that is the equation. That is Maxwell form equation. Delta S by delta V at constant T is equal to delta P by delta T at constant V. Because both are negative, so the negative sign can be removed from both sides and you get positive. Any doubts, questions? Okay. If no doubts, no questions, then we'll proceed to the last equation, fourth Maxwell equation, which is from the fourth property, which is dg. We are seen U, H, A. Now we'll use the dg with free energy function. So dg is equal to vdp minus sdt. At constant pressure, dp is 0. So it gives delta g by delta t from here at constant pressure is equal to minus s. Then we differentiate with respect to P at constant T. And what we get is delta square G by delta P delta T equal to minus delta S by delta P at constant temperature. And what is equation 7? Then we take this same equation at constant temperature. dt becomes 0. So what you get is delta G by delta P at constant temperature is equal to V. And then differentiate with respect to T at constant volume. And what we get is delta square, sorry, this should be G, not V. Delta square G by delta P delta T is equal to delta V by delta T at constant volume. So if you compare this equation 7 and 8, considering this as G, left hand side is the same, so right hand side has to be equal. So what we get is delta V by delta T at constant volume is equal to minus delta S by delta P at constant temperature. This is the fourth form of Maxwell equation. Any doubts, questions on these four Maxwell equations? If you have any questions, please let me know before we proceed to the mnemonic diagram for Maxwell equations. Dikshita,
Yes, sir.
is it okay? Is it clear or you have any doubts?
No, sir, it's clear.
Hello, can you guys hear me?
Yes, sir.
Yes, sir.
So is there any doubt? Is it or is there any is it clear or do you have any doubts for this? Because similar lines, we do one derivation, we can do similar derivations using du, dh, dA and dg. Four fundamental property relations. Use a starting point, take derivative with respect to one variable, one independent variable, then derivative with respect to second independent variable. Left hand side will be the same in both the equations. So if we use the function of v and t, v and s, so independent variables are volume and entropy. So we take derivative with respect to volume first, and then with entropy. The next time we take derivative with
Sir,
respect to entropy, and then with respect to volume. So we get two equations.
sir,
Left hand side will be the same for both the equations. So right hand side has to be same, equal. So that gives us the Maxwell equation.
sir,
Same we do for all the properties. Yes.
sir, this should be dabba V by dabba T at constant pressure.
Yeah, that should be constant. Yeah, daba v by daba. You're talking about equation 8, is it?
Yes, sir.
Let's see. Yeah, it should be daba p. Yeah, it's a mistake here. Here it should be g, it should be p here. It should be p. Yeah. I think here I've written correctly. No, here it's also it's wrong. Daba is by daba p at constant temperature. And just a minute. Yeah, daba v by daba t at constant pressure. Constant pressure, not v. Yeah, because this is g, right? So p and t. Yeah, right. It should be constant pressure. ठीक है और कोई डाउट है और कोई कमेंट है yeah there's a mistake there that derivation I have written it wrongly और कुछ है किसी को डाउट क्वेश्चन okay so if not then let us go to mnemonic diagram for
सर
yes
सर क्या मिस्टेक है
मिस्टेक क्या है दीक्षिता बताओ ना क्या मिस्टेक है
Uh, it should be dabba V by dabba T at constant pressure and not volume.
should be constant ये जो है ना क्वेश्चन 8 में डबा बी बाय डबा टी एट कांस्टेंट प्रेशर चाहिए here if you see this g is a function of pressure and temperature right तो कांस्टेंट टेम्परेचर आएगा ही नहीं, कांस्टेंट वॉल्यूम आएगा ही नहीं. इट शुड बी कांस्टेंट प्रेशर एंड कांस्टेंट टेम्परेचर, राइट? बिकॉज वी आर कीपिंग प्रेशर कांस्टेंट वन टाइम टेम्परेचर कांस्टेंट, राइट? तो यहाँ पर कांस्टेंट टेम्परेचर है, ठीक है. यहाँ पर कांस्टेंट प्रेशर आना चाहिए. ये यहाँ पर एट कांस्टेंट पी चाहिए, एट
yes,
कांस्टेंट पी. ये किया था ना हमने पहले, टी एट कांस्टेंट वी, टी एट कांस्टेंट पी चाहिए यहाँ पर. तो ये पी आ जाएगा यहाँ पर. तो यहाँ पर लिया हमने बराबर डबा डबा स्क्वायर जी चाहिए यहाँ पर बाय डबा पी डबा टी, and this should be daba v by daba t at constant pressure. So this will become daba v by daba t at constant pressure, and this is correct. ठीक है, समझा गया? I'll correct
yes,
this
sir.
and give you the notes. बुक में करेक्ट है, यहाँ पर मेरे लिखने में गलत हुआ है. ठीक है. So let's go to the mnemonic diagram and see how we can derive the Maxwell equations. See the first one, this document I scanned yesterday using Adobe, and today I use Microsoft Lens for scanning. See the difference in scanning. पीला पीला आया पूरा. Rotate. So this is what we already seen. Differentials obtained from variables adjacent to energy property A, G, H and U हमने देखा था अभी. Coefficients obtained from variables that are diametrically opposite to those variables, right? So we have seen this. कहाँ गया? So A के लिए T और B रहेगा, G के लिए T और P रहेगा, dt और dp. H के लिए ds और dp रहेगा. So for A it is dv and dt, for G is dt and dp, H is dp and ds, and U it is dv and ds. And the coefficient is diametrically opposite जो आएगा, temperature for ds, pressure for dv, and entropy for dt, and pressure for dv. That's what it is saying. Output is really bad from Microsoft. Okay, the sign of the coefficient from the direction in which arrows are pointing. So if the arrow is pointing away from the canonical variable, the coefficient is positive. If the arrow is pointing towards the canonical variable, the coefficient is negative. What that means is canonical variables are ds और s, p, t and v. तो ds लेंगे हम, और अगर u का ले रहे हैं हम u में, so v, dv and ds. So TDS will be negative because arrow is pointing away from, positive, and here it is negative because it is pointing towards. Pointing away is positive, pointing towards is negative. वही किया था हमने अभी जब डिराइव किया था पेंट में. Now let us see for the Maxwell equations. So Maxwell equation में partial derivative is found by canonical variables. So if we take, let me see if I can show this also. Okay. So partial derivative is found by canonical variables. So if we take, suppose I take this A, the canonical variables are v and t. That means A is a function of v and t. So partial derivative is found by those two variables. I can take dava v by dava t, or I can take dava t by dava v. Doesn't really matter. Either I go clockwise or I go counterclockwise. I'll get all four equations. Same four equations. Okay. So what I have done is I have taken dava t by dava v. So take these two canonical variables and take dava t by dava v. There's a derivative. The suffix to be used is the variable that is diametrically opposite the first variable, or that is the numerator. So dava t by dava v लिया तो इसका कोफिशिएंट जो रहेगा इट विल बी t के अपोजिट में s, right? So it will be s will be s dava t by dava v. Okay, the suffix to be used is a variable that is diametrically opposite the variable first variable, that is numerator. So s. Right? And then one of the partial derivatives will be dava t by dava v. Sorry, it is at constant entropy, so that's not coefficient, it is dava t by dava v at constant entropy. So that's what we'll get here. Dava t by dava v at constant entropy. The other derivative is obtained from the opposite side of the square in a similar manner. So opposite side में क्या आएगा? Dava p by dava. So you have to see if you are taking dava t by dava v, you take dava p by dava s. If you take dava v by dava t, then dava s by dava p. Same order, same direction. So dava p by dava s at constant volume. Dava p by dava s at constant volume. ठीक है? Since the direction of the arrows is opposite, that is towards t and away from p, arrow is towards t and away from p, so the sign will be opposite, that means negative. If it is towards both, it is positive. If it is towards away from both, it is positive. How many people did not understand this?
सर
साइन कन्वेंट
नहीं समझा?
सर मुझे नहीं समझ
किसी को नहीं समझा? Okay, so let's see if I can draw and show it.
हेलो
Yeah.
सर किसी भी एक मैक्सवेल इक्वेशन लेके उसमें से समझाइए
Yeah. Let me share this thing first. I'll tell you. So can you see this paint now?
यस सर
So A is a function of V and T. So V and T we had here. G is a function of T and P. So we have P here. H is a function of P and S. So S comes here. And this is a function of V and S. Okay? So we can go this way or we can go this way. Doesn't really matter. You'll get the same four equations for the four sides. So if I start with this A, we have two variables here, canonical variables, T and V. So what we can take is dava T by dava V, dava T by dava V. And we have this arrow here pointing upwards. And we have this arrow here pointing upwards. ठीक है? Mnemonic diagram का ऐसे रहता है. So we have this dava T by dava V and इसका जो subscript रहेगा और suffix बोलो कुछ भी बोलो, it will be opposite to numerator जो रहेगा वो term. Okay, सो ए के लिए ये एक टर्म ये हो गया, सेकंड टर्म इज फ्रॉम द अपोजिट साइड। अपोजिट साइड में अगेन हैव टू टेकन दिस बाय दिस और टेक दिस बाय दिस, सो डबा पी बाय डबा एस एट इसका सफिक्स विल बी वी। ठीक है, ये दो टर्म कैसे आया समझ में आया क्या?
Yes, sir.
You got these two terms कैसे आए? Now what you have to see is temperature है और pressure है, right? One arrow is pointing towards T, one arrow is pointing away from P, right? Pressure को opposite direction में arrow जा रहा है और ये arrow towards T जा रहा है, तो यानी ये हो जाएगा माइनस। अगर दोनों सेम डायरेक्शन में है, दोनों टुवर्ड्स टी और पी रहते हैं तो पॉजिटिव होता है, दोनों अवे फ्रॉम टी एंड पी रहते तो पॉजिटिव होता है। अपोजिट डायरेक्शन से जा रहे हैं एरो, इट्स टुवर्ड्स टी एंड अवे फ्रॉम पी, तो इट इज नेगेटिव। समझ में आया साइन लैंग्वेज, साइन कन्वेंशन? एनी डाउट्स ऑन दिस बिफोर वी प्रोसीड टू द नेक्स्ट इक्वेशन? समझा क्या? किसी को डाउट है तो पूछो अभी। Okay, so if not, then let us go to the next one. So I can write anything. I can write say डबा P by डबा T, right? तो इसमें क्या हो जाएगा, सफिक्स क्या हो जाएगा इसका? P के अपोजिट में क्या है?
V.
So if I taking this and this, I will take a डबा S by डबा V, right? अपोजिट साइड में, और इसका अपोजिट में क्या है?
T.
अभी साइन क्या हो जाएगा? टुवर्ड अवे फ्रॉम P है and away from S है, right? So arrow is pointing away from pressure and also away from entropy, so it will be positive. Is there a equation like that? है क्या इक्वेशन ऐसा? एक्चुअल इक्वेशन देखा था क्या ऐसा? नहीं है आपके पास, देखा नहीं है?
हाँ सर
है ना?
Yes, sir.
So you take any or doesn't matter, you get the same equations. So now we go to H. H में I'll take suppose ऐसे डबा S by डबा P. Opposite to S is T. Okay. इसका अपोजिट में क्या है? यह है, तो डबा V by डबा T. V के अपोजिट में क्या है? प्रेशर, राइट? सो साइन क्या रहेगा? अवे फ्रॉम S एंड टुवर्ड्स V, बराबर? सो नेगेटिव आएगा। ऐसा इक्वेशन यू डोंट हैव नोट्स, इज इट? नोट्स को लेता है कि नहीं लेता?
Yes, sir. Equation.
लेता है ना? इक्वेशन है क्या ऐसा?
Yeah.
यस और नो?
Yes.
Yes, sir.
Okay, so then finally we go to this side, U के लिए, so we have डबा V by डबा S, और V के अपोजिट में क्या है? प्रेशर है। सिमिलरली यहाँ पर लिया V और S लिया तो T और P लेना पड़ेगा, और T के अपोजिट में क्या है? एंट्रोपी है, बराबर? साइन कन्वेंशन क्या होगा? V के इट इज टुवर्ड्स V एंड टुवर्ड्स T, so साइन विल बी व्हाट?
पॉजिटिव।
पॉजिटिव, राइट? सो है क्या ऐसा इक्वेशन?
Yes, sir.
है ना? So we go any direction. You have to go clockwise or counterclockwise. Use all the canonical variables. You get the same 4 equations. ऐसा उल्टा भी किया तो भी same equations मिलेंगे हमारे को, because we are using opposite sides. Correct? इधर से लिया तो ये और ये आएगा, फिर इधर से आया तो ये और ये आएगा. इधर से लिया, see, if you take A and A, starting with A, so you have V and T and opposite में S and P. We start with U, we have V and S and opposite में T and P. If you take H, S and P and opposite में V and T. G में लिया तो T and P opposite में V and S. So either way doesn't really matter because you are taking opposite sides, right? U के साथ G का होता है, A के साथ H का होता है. तो whether I go clockwise or counterclockwise, I will get the same equations. So any doubts, questions on mnemonic diagram? Axial equation, mnemonic diagram generally final exam में आता है. Fundamental properties भी आता है. अभी आपका फाइनल एग्जाम होगा कि नहीं पता नहीं मेरे को, बट हुआ तो आ सकता है. किसी को क्वेश्चन है, डाउट है तो पूछो अभी, बिकॉज इट्स नॉट इजी. वंस यू अंडरस्टैंड इट्स वेरी इजी. That is why it is called mnemonic. This is especially, I mean, meaning it is memorizing. Memorize कैसे करने का. If you draw this diagram, you can remember all the equations, or you can write all the equations.
So what kind of questions can probably come on this?
Derive Maxwell equations and explain mnemonic diagram. Derive fundamental relations. ऐसे ही रहता है. टर्म में कुछ कुछ डेरिवेशंस ही आते हैं, न्यूमेरिकल भी रहते हैं, बट some questions are based on theory. Yes, so derivations do come.
Okay, sir.
और अगर आप NPTEL कोर्स कर रहे हो तो वहाँ पर MCQ रहते हैं और न्यूमेरिकल रहते हैं. There is no theory questions. फाइनल एग्जाम में भी मोस्टली इट इज MCQs and numericals. Small numericals, very small numerical 2 marks, and big numericals 5 marks. तो कितना लोग का भी NPTEL रजिस्ट्रेशन हो गया? I saw the big list Shivani had sent me. Has there been any increase of number, Shivani?
So 1 or 2 students more have enrolled.
Okay. और mentors कितने लोग का असाइनमेंट हुआ है, कितने लोग का नहीं हुआ है? Because I checked, I was seeing only 10 or 12 students who had assigned me as mentor.
सर मुझे आपका नाम ही नहीं दिख रहा है वहाँ पे.
अरे कैसे नहीं, मेंटर है, 10 लोग ने असाइन किया तो आपको भी दिखना चाहिए ना.
सर
लैपटॉप नहीं,
3
मोबाइल
जनों
नहीं
ने
होगा.
ट्राई किया मेरा.
हाँ,
3 लोगों ने ट्राई किया पर हो ही नहीं रहा है, वो आपका नाम ही नहीं आ रहा है.
बाकी लोग ने, मैं what I will do is I will send you a list of people who have assigned me as mentor. You can ask them because I cannot see. Because I am a mentor, I won't see your view of NPTEL. It's very difficult for me to help you there. So you can ask others who are successful in assigning me as mentor. तो उन्होंने कैसे किया? It's not very different from others. 10 लोग कर सकते हैं तो बाकी लोग भी कर सकना चाहिए. Only thing is you have to have a laptop or PC. मोबाइल पर शायद वो ऑप्शन अवेलेबल नहीं है, फीचर अवेलेबल नहीं है. Because I think today is the last day for registration for the course. I don't know mentor assignment के लिए क्या लास्ट डेट, वो भी शायद आज ही लास्ट डेट होगा. So try today. I'll send you a list of people who have already assigned me as mentor, then you can talk to them. ठीक है? Any questions, doubts on what we have seen yesterday and today? Fundamental property relations, Maxwell equations, and mnemonic diagram. No? That's good. If you don't know doubts, then it's very good. I just wanted to ask you, somebody said yesterday chat nahi ho raha hai. You are not able to chat, right? Shivani, can you try sending a message if you are able to chat?
Yes, sir. I will try.
Just try if you are able to send something.
सर म्यूटेड दिखा रहा है चैट में.
Muted दिखा रहा है. Okay. So I'll do one thing. I have said that presenter is only me. and इसलिए शायद ये डिसेबल हो गया होगा. Let me see if I can change the properties. How to change the properties? Okay, Shivani, now try. Whether you are able to send message, chat message.
No, sir. I'm not able to send.
Okay, so maybe there is some other setting. Because now I have made everybody a presenter. So presenter को chat होना चाहिए because I am able to chat. Because I am able to send you message. You chat. Your message.
हाँ सर.
Just in chat में डाला है. Now I have made change the rights of everybody. Everybody is a presenter. So I am able to send a message. You should be able to send a message. एक बार फिर से try करके देखो.
सर मैसेज दिख रहा है पर
Send नहीं हो
रिप्लाई
रहा.
रिस्ट्रिक्टेड करके दिखा रहा है.
हाँ, वो देखना पड़ेगा सेटिंग क्या है. बिकॉज आई हैव मेड एवरीबडी प्रेजेंटर. प्रेजेंटर सब कुछ कर सकता है जनरली. पहले नहीं था. पहले आई हैड सेड ओनली आई एम द प्रेजेंटर. बट नाउ जस्ट नाउ आई चेंज द सेटिंग. बट स्टिल इट इज नॉट वर्किंग. तो फाइंड आउट करना पड़ेगा मेरे को क्या है. लेट मी फाइंड आउट. आई विल डू दैट. ओके. So if you don't have any other questions or doubts, suggestions, if you have suggestions, let me know. This is working for you. Paint was okay. You were able to see what I was drawing on paint.
Yes, sir.
Yes, sir.
Sir.
We use paint instead of whiteboard. Sometimes you have to
Yes, sir,
draw
that's
and show. क्या बोले?
बेटर सर. व्हाइट बोर्ड पेक्षा चांगले आहे सर.
व्हाइट बोर्ड से अच्छा है. ठीक है. गुड. See, ultimately, what I show you should be able to see. If you're able to see, that's good. If you're not able to see, then it's bad. Okay, so I'll stop the recording now. You can see the recording if you want to.